At the core of digital tools is the ability to store geometric information in the form of digital files. For CAD software, this falls into two categories: native file formats and neutral file formats. Native file formats are the file type used by specific CAD packages. They store all of the software-specific information, for example settings, model history, or layers required to continue modeling the geometry when the file is reopened, or when opening a shared file from the same software. As these file types are intended for use with a specific piece of software, it is not always possible to open the files with an alternative modeling software. There are almost as many native file formats as there are modeling packages. This makes sharing our designs more challenging. However, software is getting better at being able to read these models from other software packages. To enable sharing between software, neutral file formats are used. These file types do not store as much software-specific data as native file types. Instead, they reduce the information to the key geometric data. There are two main forms of neutral file type. The first are BREP files, the most common being STEP and IGES. Both file types describe geometry using a collection of connected surface elements, making them suitable for applications where more precision is required. The files are usually described as dumb file types, as they store limited information outside of the geometry. But when we open the BREP file types in CAD software, it may be possible to modify them or to use them as the basis for a new design. Other neutral file types are tessellated 3D models, and these geometric information is stored in the form of triangulated surfaces with shared points. Historically, the most commonly used file of this type in 3D printing is the Stl file. This extremely simple file contains a list of small triangular surfaces. They are very well suited to the software used to process the geometry into machine commands, but they do not store the geometric information in as accurate a way as BREP files. More recently, the industry has developed the 3MF file, which can contain more information specific to 3D printing, as well as checks and balances to reduce the errors of use in these files. These tessellated models have even more limits in their reuse or modification. Traditional CAD packages struggle to modify these geometric types, and if modification is required, specialist tools and digital sculpting approaches are most commonly used. While working on a design, it's best practice to save the CAD in the package's native file type. When sharing the files for reuse or modification, if possible, also use the native file type. Where the CAD package used by the recipient is unknown and precision is required, BREP files like STEP are more suitable. And finally, if sharing for 3D printing, STL or 3MF files are more likely to be used.